good way to think of antimatter is as sort of a mirror image of normal matter. For some reason, the universe is made of matter. We don't know why that is, because you could, in principle, make a universe out of antimatter. Antimatter is identical to matter, but has opposite properties. For example, the fundamental particles that make up atoms, protons and neutrons and electrons, they have antimatter equivalents, antiprotons, antineutrons, and positrons. Antiproton has the opposite charge of a proton. A proton is a positive charge, antiproton has a negative charge. The thing is, we have to make antimatter in the laboratory. Nature didn't provide us any. It seems to have disappeared shortly after the Big Bang. So we have to make it if we want to study it. What alpha does is to work with the simplest anti-atom, anti-hydrogen. Hydrogen is number 1 on the periodic table. Antihydrogen is the antimatter equivalent.
Matter and antimatter together, because the hallmark of that happening is that the two annihilate together, releasing photons of light normally. But to put it in, to give you a sense of scale, if I have a quarter of a gram of antimatter meeting a quarter of a gram of normal matter, that gives me the explosive force of 5 kilotons of TNT, but only because I have so much antimatter there. So holding on to antimatter in your hand to study it is a bit of a big deal because of this behavior of antimatter and its tendency to annihilate. So I have with me here in the room, out of sight, Rolf, come into shot.
Yeah. Oh.
Rolf Landauer, who is going to show us how we can actually hold samples of anti-atoms and stop them doing this. So Rolf, how do we do that?
Well, actually, I mean, I can show you something which comes out of a Hollywood movie. You know, you see this little trap here, you know? That's what they used in the Hollywood movie to store 1 gram of antimatter. Okay, well, I mean, that's not completely true, okay? So it's not really possible to store 1 gram of antimatter in there, especially not when it's neutral, like antihydrogen and so on. But actually, you could store a few antiprotons in there, even quite a few, something like 1 billion or 10 billion or so. And the way you do is actually without touching it. You know, the key is you mustn't touch antimatter, because you are made of matter, and if you touch antimatter, then that's a bad thing, you know? So the best thing is to keep it with magnetic field and electric field in position in the middle of this container here, which is basically evacuated. There's no air inside, okay? And you can see where this little LED is. This there would be the antimatter.
You mean it's not antimatter in there?
It's not antimatter, but I know you are disappointed now. And yeah, actually, well, we tried once to do it, but it would have been too expensive to make such a thing, you know, to transport antimatter around. But anyway, in the real life, you know, you would use kind of a magnetic field in order to make these charged particles spin around these magnetic field lines, and then you use electric fields to keep them from touching the magnet in some sense. This is basically the principle. And of course, vacuum is important, okay? So it's just really very well evacuated. But that's in a nutshell how you keep charged antiparticles. And that's also, I think, what Niels in principle uses in his experiment, where you want to store antiprotons or positrons. This is sort of the basic principle, okay? So you see now, of course, you see here these LEDs, and by midnight this will explode, okay?
The latest spectacular surprises of our Milky Way galaxy is a mysterious cloud glowing in gamma rays produced by the annihilation of matter-antimatter particles. NASA's orbiting Compton Gamma Ray Observatory, which mapped the center of the galaxy, observed that gamma rays coming from electron-positron annihilation form a bright spot at the center, with a fainter horizontal emission from the galactic plane. What is even more astonishing to astronomers is that the map also shows a broad distribution of the same annihilation radiation, extending in a region some 3,000 light-years above the galaxy disk. This seems to imply that a fountain of antimatter positrons streams from the center of the galaxy. What could have created this cloud? The likely suspect is the black hole, estimated 1 million times the mass of the Sun, thought to reside at the core of the Milky Way.